this pelvic incidence should be equal to pelvic tilt and sacral slope. And the lumbar lordosis should be equal to, should be related to pelvic incidence plus or minus 9. Then about the pelvic retroversion. So here now assume that here is a C7 vertebra, and when you drop a C7 plumb line, the SVA is far more positive from the posterior superior aspect of S1. So it should be more than say about more than 10 centimeter, where it more than that's about plus 10 centimeter. For example, so the normal reference range is only maximum up to plus 4 centimeter. So anything more than that will result in the forward stooping. Okay, so in order to counteract such an increased SVA, what happens is the pelvic tilt gradually increases. It compensates for the more and more of a positive sagittal balance. And finally, it increases, the pelvic tilt increases to almost 25 degrees. Then that is what we say it as pelvic retroversion, where the entire sacrum, the sacrum assumes a vertical position in relation to the femoral head. So as pelvic tilt increases, the sacral slope also decreases. See the sacral slope, this is the sacral slope. The sacral slope gradually it decreases and almost becomes very close to the horizontal line. So as pelvic tilt increases, the sacral slope decreases because the sacrum assumes a more vertical position in relation to the femoral head. So this is a compensatory mechanism used to sagittally rebalance the spine. So because the pelvic tilt has increased, now see from how the spine is here and how the spine is here. So that is to assume to correct the sagittal imbalance or to realign the sagittal balance. The pelvic tilt increases to as a compensation for the positive sagittal balance. So normal gait, it requires the forward flexion of the pelvis. Normal gait requires a forward flexion of the pelvis. But because of this increased pelvic retroversion, this causes more energy consuming and increasing muscle effort for the standing. So here, the Dubocet's cone of economy gets breached. So this acts as a cause of pain and disability. So that is why for everything, for all the parameters, ultimately the cone of economy has to be correlated for the better understanding. So once again, I repeat, the pelvic retroversion. In the pelvic retroversion, so what is this pelvic retroversion is that when you have a positive sagittal balance, when you have a positive sagittal balance where your SVA is more than pelvic retroversion for lumbar stenosis, a portion of the pelvic retroversion can be compensatory for distal lumbar stenosis as well as for sagittal imbalance. The lumbar spinal stenosis is significantly associated with the flexible deformities. The flexible sagittal imbalance is a 10-degree change in lumbar lordosis between the weight-bearing and the non-weight-bearing images. So that means we have to take two kinds of a whole spine X-ray. That is one in standing position. That's what that is commonly we do. And we also need to take a whole spine X-ray in the supine position also to see whether there is any change in the lumbar lordosis. When there is a change of almost 10 degrees, we say it as a flexible sagittal imbalance. So the importance of these spinopelvic parameters, when you have a high pelvic incidence and pelvic tilt, they are a predisposing factor for facet joint degeneration at the lower lumbar spine. When there is an increased pelvic tilt values reflecting the pelvic retroversion, and it correlates with the HRQL, that is the health related quality of life scores. The T1 spinopelvic inclination was more accurately correlated with the HRQL scores than did the SVA. So our target for our goal for surgical correction should be the SVA less than 5 centimeter, T1 spinal pelvic angle less than 1 degree, and the pelvic tilt of less than 20 degrees. So the relationship between the pelvic incidence and the lumbar lordosis is another important parameter which needs to be maintained. So when there is a lack of pelvic compensation for a high SVA, so when there is no pelvic retroversion or an increased pelvic tilt for the high SVA, so what happens? So this pattern may be seen in patients with a pre-existing hip flexion contracture, when there is a failure of the hip extensors, when the patient is having a degenerative flat back with a primary extensor muscle pathology, or there can be a secondary extensor muscle weakness, and the patient is leaning forward to compensate for the severe lumbar stenosis. So this is just summarizing the same, the pelvic parameters. So when there is an increasing SVA, the pelvic tilt increases and the sacral slope decreases. So the SVA increases result in the compensatory increase in pelvic tilt. As pelvic tilt increases, the sacral slope decreases and pelvic incidence remains constant. The same picture has been explained here. So then as the adult scoliotic deformity. So ASD means it is the adult scoliotic deformity. So there are this classification alone, I have taken it for the sake of understanding the sagittal balance of spine, or how the sagittal balance of spine has been applied in case of degenerative scoliosis. So we not only the adolescent idiopathic scoliosis, the AIS, it is very, very important in cases, also in cases of degenerative scoliosis, that is the adult scoliotic deformity. So that is the SRS Schwab classification, where the coronal curvature has been used and 3 sagittal modifiers has been used. So we are not discussing about the coronal alignment today. So we'll restrict ourselves to the sagittal parameters. So the 3 sagittal parameters which is being used in this era, SRS Schwab classification. SRS means it's a Scoliosis Research Society. The 3 parameters which has been used is the pelvic incidence minus lumbar lordosis. So this should be usually less than 10 degrees. If it is between 10 to 20 degrees, it is moderate deformity, and more than 20, it is marked deformity. And the global alignment, that is this SVA. If the SVA is less than 4 centimeter, it is neutral, and if it is normal, 0, and if it is more, if it is between 4 to 10 centimeter, it is considered as a positive or moderate deformity. If it is more than 10 centimeter, we say it as a marked deformity or 2+. And then the pelvic tilt. If the pelvic tilt is less than 20 degree, it is non-pathologic. If it is between 20 to 30, it is moderate deformity. And if it is more than 30, it is a marked deformity. The surgical management. Say I put up a few words just pertaining to the parameters which we have discussed. The many parameters are yet to be discussed, because in the subsequent thing, we will also discuss about the sagittal alignment of the cervical spine also. So there are certain parameters for the cervical spine, and whatever we have discussed now, the relationship with, there is something called as proximal lumbar lordosis and distal lumbar lordosis, and its relationship with the sacral slope and the pelvic parameters. So there is something called the proximal lumbar lordosis, distal lumbar lordosis, proximal thoracic kyphosis and distal thoracic kyphosis. And there is something called, also called as the inflection point. So this inflection point and these other types of lordosis and everything we will discuss in the subsequent session. Specific to the points which we have discussed, how far we can surgically apply the parameters which we have discussed so far. So the osteotomy. So you need to know the various type of osteotomies. So why we need to know the osteotomies is, the osteotomies are very, very helpful, very much helpful in the correction. So there are 6 types of osteotomies. Okay, there are 6 types of osteotomies. The type 1. See, type 1 here, the facet joint and the capsule is removed in the type 1 osteotomies. In type 2 osteotomy, the facet joint, capsule, and the spinous process is removed. In type 3 osteotomy, it's a wedge resection. It is a wedge resection. In type 4 osteotomy, you have a vertebrectomy and a discectomy. In type 5 osteotomy is an corpectomy. And in type 6 osteotomy, it is a multiple resection. It's a multiple corpectomy or a multiple resection. So these osteotomies are very, very important to correct the sagittal angles also. So when you do a posterior column osteotomy, the posterior column osteotomies are the Smith-Peterson and the Ponti's osteotomy, this type 1 and type 2, you achieve a 10 degree correction per level. In case of pedicle subtraction osteotomy, that is type 3 and type 4, you get almost a 30 degree correction at a single level itself. And when you do a type 5 or type 6, where you do an VCR, vertebral column resection, you get up to 40 to 60 degrees of corrections from a single level. A 3-column osteotomy restores the sagittal balance and correlates with the health-related quality of life outcomes. So the radiographic goals with our surgical management is SVA within 5 centimeter, pelvic incidence and lumbar lordosis mismatch less than 10 degrees, pelvic tilt less than 20 degrees, and T1 spinopelvic angle less than 1 degree or 0. The location of the osteotomies. So most oftenly, we need to do an extensive caudal osteotomies in the lumbar spine. So more caudal osteotomies are significantly correlated with greater pelvic tilt reductions, and the degree of osteotomy is significantly correlated with the changes in thoracic kyphosis. So how to do this osteotomy, or what is the location of these osteotomies? So what you have to do is draw the plumb line, draw the C7 plumb line, and draw a line along the patient's spine and measure this angle. Draw a line along the patient's spine, and then draw the corrected plumb line. Okay, this should be the corrected plumb line. So here you have the posterior superior part of S1, and this should be the corrected plumb line. And from that line, you draw a line to the centroid of the caudal lumbar vertebra. So these are the vertebrae, the caudal vertebrae, where you need to focus on more of the osteotomies, or the pedicle subtraction osteotomies, or the Ponti's osteotomies. So thus, as the pedicle subtraction osteotomy moves more caudal, the angle becomes smaller.